Good day, students. I am Daylyn Manseneros. Together with me is my co-presenter.
Good day, students, and I am Krystelle Mae Racho.
For today's lesson, we will talk about division algorithm. Division algorithm serves as a fundamental principle underlying the concept of divisibility. It states that an integer a can be divided by a positive integer b such that the remainder is less than b in magnitude. This assertion is formally expressed in Theorem 2.1. Theorem 2.1 of division algorithm states that the given two integers a and b, where b is greater than 0, there exists a unique integer q and r such that a is equal to b times q plus r, where the remainder r satisfy the condition r is greater than or equal to 0 but less than b. It says that q represents the number of times b can be subtracted from without going negative, while r is the leftover amount after this subtraction. The uniqueness of q and r ensure that any given pair of integers a and b, there's only one valid quotient and remainder that satisfy these conditions.
Now for our example problem, use the division algorithm to establish the following. The cube of any integer has one of the form 9k, 9k plus 1, and 9k plus 8. For the solution, first we will find an integer multiplied to 9 that will be equal to a perfect cube. The least possible cube number is 27. Then, we divide 27 with 9, which gave us 3. By the division algorithm, any integer n can be written in one of the forms. A is equal to 3q, a is equal to 3q plus 1, and a is equal to 3q plus 2. Now, to solve for the first case, if the remainder is equal to 0, we assume that the integer a is equal to 3 cubed. Then, we formulate the cube of the assumed integer a, which will be a cubed is equal to the quantity of 3q raised to 3. Then, to simplify the quantity of 3q raised to 3, we can use the rule of exponents that states the quantity of ab raised to n is equal to a raised to n times b raised to n. Now applying the rule, we get quantity of 3q raised to 3 is equal to 3 raised to 3 times q raised to 3. Then, multiplying 3 raised to 3 to q raised to 3, we get 27q raised to 3. Extracting factors, we get 9 quantity of 3q raised to 3. We can represent this equation as 9k, where k is equal to 3q raised to 3. Now let's proceed to the case 2. To solve for the second case, 9k plus 1, if the remainder is equal to 1, we assume that the integer a is equal to 3q plus 1. Then we formulate the cube of the assumed integer a, which will be a cubed is equal to the quantity of 3q plus 1 raised to 3. Simplify the quantity of 3q plus 1 raised to 3, we can use the binomial theorem formula that states quantity of n taken k times a raised to n minus k times b raised to k. Applying the formula, we can get the quantity of 3q plus 1 raised to 3 is equal to the quantity of 3 taken 0 times the quantity of 3q raised to 3 minus 0 times the quantity of 1 raised to 0 plus the quantity of 3 taken 1 times the quantity of 3q raised to 3 minus 1 times the quantity of 1 raised to 1 plus the quantity of 3 taken 2 times the quantity of 3q raised to 3 minus 2 times the quantity of 1 raised to 2 plus the quantity of 3 taken 3 times the quantity of 3q raised to 3 minus 3 times the quantity of 1 raised to 3. Simplifying each term, we get 1 times 27q raised to 3 times 1 plus 3 times 9q raised to 2 times 1 plus 3 times 3q times 1 plus 1 times 1 times 1. Further simplifying, we obtain 27q raised to 3 plus 27q raised to 2 plus 9q plus 1. Finally, we can factor these as 9 times the quantity of 3q raised to 3 plus 3q raised to 2 plus q plus 1. We can represent this equation as 9k plus 1, where k is equal to 3q raised to 3 plus 3q raised to 2 plus q.
For solving case 3, assume that the integer a is equal to 3q plus 2 and the remainder is equal to 2. Then the cube of the assumed integer will be 3 cubed is equal to the quantity of 3q plus 2 raised to 3. Then, to simplify, 3 cubed is equal to the quantity of 3q plus 2 raised to 3 by using the binomial coefficient formula and taking k times a raised to n minus k times b raised to k. Applying the formula, we can get a cubed is equal to 3 taken 0 times the quantity of 3q raised to 3 minus 0 times the quantity of 2 raised to 0 plus 3 taken 1 times the quantity of 3q raised to 3 minus 1 times the quantity of 2 raised to 1 plus 3 taken 2 times the quantity of 3q raised to 3 minus 2 times the quantity of 2 raised to 2 plus 3 taken 3 times the quantity of 3q raised to 3 minus 3 times 2 raised to 3. A cubed is equal to 3 taken 0 times the quantity of 3q raised to 3 times 2 raised to 0 plus 3 taken 1 times the quantity of 3q raised to 2 times the quantity of 2 raised to 1 plus 3 taken 2 times the quantity of 3q raised to 1 times the quantity of 2 raised to 2 plus 3 taken 3 times the quantity of 3q raised to 0 times 2 raised to 3. Then simplify, a cubed is equal to 1 times the quantity of 27q raised to 3 times 1 plus 3 times the quantity of 9q raised to 2 times 2 plus 3 times the quantity of 3q times the quantity of 4 plus 1 times the quantity of 1 times 8. It will be equal to 27q raised to 3 plus 54q raised to 2 plus 36q plus 8. Instructing the factor is equal to 9 times the quantity of 3q raised to 3 plus 6q raised to 2 plus 4q plus 8. Then a cubed is equal to 9k plus 8, where k is equal to 3q raised to 3 plus 6q raised to 2 plus 4q. Therefore, the cube of any integer has one of the forms 9k, 9k plus 1, 9k plus 8.
Thank you for watching. I hope you learned something from this lesson. Bye-bye!